often knowing the mean and the median isn't enough. In this case, we can turn to what are known as quartiles. There are a total of 3 quartiles. They're denoted Q1, Q2, and Q3, and they break the data set into groups of 25%. There's 25% below Q1, 25% between Q1 and Q2, 25% between Q2 and Q3, and 25% larger than Q3. When finding quartiles, the first step is to find the median. This is the value of Q2. The median then splits the data into 2 data sets. We then find the median of the lower half of the data, which is the value of Q1. We then find the median of the upper half, which is denoted as Q3. As an example, let's consider this data set here. I can see that we have the median halfway between 6 and 9. This gives me that Q2 is 7.5. This then breaks the data into 2 sets. I have 4 numbers below the median and 4 numbers above. Q1 will then be the median of the lower half, or halfway between 2 and 5, which is 3.5. The median of the upper half of the data will occur between 9 and 10, and that is Q3, which is 9.5. For this, it's important to realize that we used the values of 6 and 9 to find the median of 7.5, but these data values were still included when we find the quartiles. When we split the data set in half, even though we've used 6 and 9 to find our median, they're also used to find Q1 and Q3. This time, let's consider this data set, 2, 2, 5, 6, 9, 9, 10. We see that 6 is our median, or Q2. This is halfway. And then this gives us 2 data sets below and above the median. The median of the lower half is 2, which will be Q1, and the median of the upper half is 9, which will be Q3. This time, since we've actually found the median to be one of the data values, that data value was not included when we split our data in half. Most often, quartiles are reported as part of what's known as the 5-number summary. The 5-number summary includes the minimum, the 3 quartiles, and the maximum. Let's once again consider this data set 2, 2, 5, 6, 9, 9, 10, 12. We can see our minimum value is 2. We previously found our quartiles to be 3.5, 7.5, and 9.5. And we can see the maximum number is 12. So here we have our 5-number summary. Quartiles are used to determine what values may be outliers. The really high or really low data values that don't really fit in with the data. To determine the cutoff values for what is considered an outlier, we start with what's known as the interquartile range. The interquartile range is defined as Q3 minus Q1. We subtract the third and the first quartile. After that, we find 1.5 times the interquartile range. The outliers are then any numbers that are smaller than Q1 minus 1.5 times IQR, or larger than Q3 plus 1.5 times IQR. Let's consider this data set here. We start by finding the 5-number summary. We see that 9 is our Q2. The minimum is 2. And the maximum is 25. . The first quartile, Q1, is halfway between 2 and 5, which is 3.5. And Q3 is halfway between 10 and 12, or 11. We then find our interquartile range. This is 11 minus 3.5, which gives us 7.5. Our formulas said Q1 minus 1.5 times the interquartile range, or 3.5 minus 1.5 times 7.5, which is negative 7.75. This tells us for this data set, any value smaller than negative 7.75 would be considered outliers. We do not have any small outliers in this data set since no numbers are below negative 7.75. For the upper outliers, we had Q3 plus 1.5 times the interquartile range, or 11 plus 1.5 times 7.5, which works out to be 22.25. So any numbers larger than 22.25 is considered an outlier. In this case, we do have a data value that is bigger than 22.25. So we have that 22.25 is in fact, or 25 is in fact an outlier of this data set.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.